Hi there. I've gotten some emails from some of you asking questions about factoring, so I thought I would just make a quick video and go through the different factoring methods that we've had. We started with backwards distributive, then we did backwards FOIL on trinomials, and then we also did the difference of squares, the difference of cubes, and the sum of cubes. We finished by doing factoring by grouping. So let's start with pulling out the greatest common factor, because that's always the first thing you should look for when you are told to factor a polynomial. Okay, when I look at this polynomial, the first thing I want to do is look at the coefficients, 6, 15, and 21. And I ask myself, is there a number that will go into all three of those? And if so, what's the largest number that will go into all three of those? The answer to that, for this particular problem, is the number 3. So you write down a 3. Then you look at the x variables. You've got an x squared, and an x to the fourth. The greatest number of x's being multiplied in any of the terms is 2. So we would say and x to the second is a common factor for all three terms. Then I look at the y's. I've got a y to the fourth, y to the fifth, y to the third. Y to the third would be what they all have in common, so I would write down y to the third. Write down your parentheses, and note that if you have 3 terms in your original polynomial, you must have 3 terms in your parentheses after you've pulled out the greatest common factor. Now at this point, it's backwards distributive. I have to ask the question, 3x squared y cubed times what will give me 6x squared y to the fourth? Well, I need 3 times 2 to get the 6. The x squared is already there, so I don't need to multiply another x. Y cubed times y to the first would take care of the y to the fourth. Now, anytime you have a variable with an exponent of 1, you could leave that off and it still means the same thing. Alright, put down my minus sign, and then I say 3x squared y times what will give me 15x squared y to the fifth. Well, I need a 3 times 5. I don't need anything for the x squareds because it's already there, and then I need a y cubed times y to the second. Then I go to the last term and do the same thing. I put my sign down, and then I say 3 times what will give me 21. That's 7. X squared times what will give me x to the fourth. That's x squared. And then y cubed times what will give me y cubed. Well, I could put a 1 there if I wanted to, but I don't need that, so I can just leave it as 7x squared. That's an example of pulling out the greatest common factor, and you always need to do that no matter what the problem looks like. Even if it's going to be one of the other methods, you still first look for the greatest common factor. Okay, let's take a look at FOIL. When I multiply two binomials, I multiply the first terms, the outside terms, the inside terms, and the last terms. That's F-O-I-L. That stands for FOIL. Now I can combine those a little bit and simplify that to x squared minus 4x minus 21. The middle term is often simplified by just adding the O and the I. Okay, let's take another look at where those terms came from. The x squared came from the x and the x. That's the F of FOIL. The minus 21 came from the L of FOIL, the plus 3 and the negative 7. The negative 4x came from adding our O and our I. So if I were going to go backwards and say what two binomials did that come from, I would do the same type of thing. I know that this has to be x and x, and then I look at the last terms and they have to multiply to give me 21. Well, my choices are 1 and 21 or 3 and 7. Now, One of them has to be positive and one has to be negative because that's the only way I can get a negative product. So I start putting the numbers in and I check my O and my I and see which one will give me a negative 21. If I try, let's say I put a 7 and a 3 and I think that this is minus and this is plus, check your O and your I. I get a negative 3x and I get a plus 7x. When I add those together, I get a positive 4x, so I know then that that's not the right answer. The correct answer would be to put a minus 7 here and a plus 3, because then my O and my I give me negative 7x plus 3x, which does indeed give me negative 4x. Okay, let's look at a different problem, starting with the binomial. Let's see if we can work our way back to the trinomial. Okay, now let's start with the trinomial and see if we can factor it into the two binomial factors that I multiplied to get that. The x and the x will be automatic because that's the only way I can get x squared is x times x. Now for the 63, I need to look at the different combinations that I can multiply to get 63. I can have 1 and 63. I could have 3 and 21. Looks like I could have 7 times 9. And now, along with considering those combinations, I also need to consider that one of them has to be negative. So it's a trial and error. I start putting them in. If I put in a plus 3 and a minus 21, and I check my O and my I, I'm going to get negative 21x plus 3x. That does not give me a minus 2x. Remember that I'm trying to get my O and my I to give me a negative 2x. So I would erase that. Now I would try another combination. So let's say that I'm going to try a plus 7 minus 9. Again, I'm going to check my O and my I. My O gives me minus 9x. My I gives me plus 7x. Together that's a minus 2x. Okay, that is the correct answer, which means what I have here is the way that you would factor that polynomial into two binomials. Alright, now before we leave this, I do want to take a look at the little shortcut that you probably remember from Algebra 1. Alright, so I'm looking at this as a new problem again. The shortcut is to ask yourself what two numbers multiply to give you negative 63, add to give you negative 2. Now this shortcut only works if there is no coefficient in front of the x squared, which means there's really a 1 even if it's not written. So if I look at my box of numbers here, the two numbers that could possibly multiply to give me 63 and add to give me 2 would be the 7 and the 9 if I make the 9 negative and the 7 positive. So I would put plus 7 minus 9, and that would be my answer. Okay, let's look at another trinomial. This one, you'll notice, has a coefficient in front of the x squared that's not 1. What that means is I'm going to have to look at the possibility that my answer is 6x and 1x, or it might be 3x and 2x. When that happens and you have more than one option, I usually like to write my choices for my F on the left, and then I write my choices for the 15, which represents my L, on the right. Okay, now, these are my choices for L, these are my choices for the coefficient on my X for my F. I need to test the O and the I and see which combination is going to give me a negative 19x right here. Alright. Okay, now I've put my first pair in, a negative 9 and a negative 15. Now the reason I'm using two negatives is I know that my product has to be a positive 15, And since my sum in the middle is negative, most likely that means that I'm going to need two negatives. So if I check that, I have negative 90x minus 1x. Alright, that does not work. When I switch the two numbers around and put the minus 15 first and check my o and my I, it still doesn't give me a negative 19x. I get negative 21x. Alright, since 1 and 15 did not work, I need to test 3 and 5. So I put in a minus 3 and a minus 5, and I get negative 30x minus 3x. That does not give me negative 19x. When I reverse the numbers, my o is negative 18x, and my I is negative 5x. Those add to give negative 23x. That still doesn't work. So now I've eliminated the 1 and the 15 and the 3 and the 5 being paired with the 1 and the 6. That means this is not going to be the pair that works, and I need to look at the 3x and the 2x. So if I put, let's say I put a minus 5 here and a minus 3 here. Let's see what happens. I get negative 9x, and then my I is negative 10x, and that gives me negative 19x. That's exactly what I was looking for that middle term. Now, I didn't even need to test the 1 and the 15 because I found the correct answer. So this right here is the factoring correctly of 6x squared minus 19x plus 15. Sometimes you'll hit it on the first try, other times it'll be the last try. As you get better and have more experience, you will learn to look for a few things, and you'll make wiser choices from the outset. But until then, you just really have to gain some experience. Okay, let's look at what we call the difference of squares. When I do FOIL on this problem, I get x squared plus 7x minus 7x minus 49. The o and the I term cancel each other out, and I end up with x squared minus 49. We call this the difference of squares. The first term is a perfect square, the last term is a perfect square. And now take a look at where it came from. Okay, following the pattern of the last problem we just had, I know this is x and x because x times x gives me x squared. What's going to go in the other two blanks is a 6 and a 6 because that's what I multiply or square to get 36. Now the only way the o and the I are going to drop out is if one of these is a plus and one is a minus. Okay, that's the end of the first video. We looked at taking out the greatest common factor, doing backwards FOIL, and also looking at the difference of squares. Part 2 we'll look at factoring by parts and the